Good morning, everyone. Um, and to introduce myself, Sanjay Mistry. I am 2011 pass out from our IC department and currently working in Yokogawa India Limited as assistant manager in service department. So today we are here for our Arduino introduction webinar. So I think you have heard the name Arduino many times from any website or friend or any project or college or any staff. So anyone knows what is the Arduino? Can any student tell me what is Arduino? What do you think about Arduino?
Hello, Arduino is one type of microcontroller which can do operations as we give them instructions.
Okay. Uh, any other? Any student? Okay. Let's see. So Arduino, it is not a microcontroller. Arduino is a term which is used on many websites or globally for embedded world. It is a common term. Actually, Arduino it is not a single thing or microcontroller. Arduino is an open source computer hardware and software company, or you can say it is a project, and it is a user community that designs and manufactures such a single board microcontrollers. The kids are building many digital devices which can be used for science and control objects. Arduino is not a single component. It is started as company, and it is termed as the Arduino project also, and it is a user community. You can see the logo. So Arduino board designs are using a variety of controllers. The boards are having few digital analog I/O pins that may be interfaced to various expansion boards, series, and other circuits. We will see that shields and other circuits in for the presentation. So there are different type of boards and which have different type of different numbers of I/O and different memory and different type of shield. The shield I will see you later. The what is shield? So let's start where it began. Its history. I will tell you why I'm explaining the history. So Arduino word. It is someone's speaker is on. It is getting going. Okay. Arduino actually that name was of a bar in Ivrea that is located in Italy, where the founders of project used to meet. That was their center point to meet regarding the project. On that bar name, they have named the project Arduino. That bar name even was came from Arduino of Ivrea. Actually, that is related to history of Italy. So on that, they have named that bar Arduino. On that name of the bar, the project named Arduino. And that project started in 2003. It was actually not started by any faculty. It was started by students themselves in the Interaction Design Institute of Ivrea, which is in Italy. Their aim was to provide a low cost and easy way for newbies and professionals to create any device that interact with their environment using sensors and actuators. Because at that time, it was not an easy platform to attach all sensors and actuators with microcontrollers. So they thought that we can build a low cost and easy way for newbies, so they can use them in routine and college based also. So these are the guys who were involved in Arduino project. First one, Mr. Hernando, he has created a platform developed in his master thesis project. It was in IDIA. It is same as Interaction Design Institute of Italy. So these two guys, Messi and KZ, the project was under supervision of them. The founder's goal was to create a simple, low-cost tool for creating digital projects by non-engineers. So if someone is having less experience of embedded or is not engineer by default, so he was willing to design such a thing that anyone who is technically sound can use such a thing. So they've developed a platform called Wiring, uh, and they used 80 mega 168 microcontroller. That controller is actually called as a AVR family from Atmel, and they developed an IDE. IDE means at the platform where you can do the programming of microcontroller and created some library functions to easy to program the microcontroller. In 2003, they have added support of cheaper 80 megabyte controller. 80 megabyte is a smaller version and it is cheap. But instead of continuous wiring, they redesigned the whole project as Arduino. So maximum Arduino boards consist of 80 Atmel 8-bit AVR microcontroller. There are various controllers in this AVR family that started with 80. Then Mega, Tiny are the type of board, and 8, 168, 328 are sub-types with different IO and memory capacity. And they have different memory size and pins and features. So in 2012, they developed 32-bit Arduino board also. And these boards are having female header connections. So if you, I will show you what does this mean for female header. It is easy for connecting wires and sensors and shields also. Uh, Maximum board includes 5-volt linear regulator and 16 megahertz crystal oscillator. Uh, Crystal provides the clock cycle for that microcontroller. Uh, Maximum controllers, this 80 mega series, is having inbuilt oscillator at 8 megahertz, but those are compatible with 16 megahertz with external crystal. That I mentioned that few designs are already running on 8 megahertz. If you don't, even if you don't attach the crystal, that controller will work standalone at 8 megahertz. Uh, these was the first board they designed with 80 megahertz controller, and it was having the serial port for programming. Uh, Onboard voltage regulator IC you can see. This is the main controller, 80 megahertz controller. Uh, This is the crystal what I was talking about. External crystal they are added, but now this board has been retired because uh, uh, it has been years of development. So they are retiring with the board after few years. This is another board. It is having 80 mega 168 microcontroller. That board name, uh, it was on. They have sorry, just a minute. Ah, Once they have sold the 10,000 Arduino boards, on that they have named this board name. That word Dicimilia means 10,000 in Italian, so they named it Arduino Dicimilia. It is if you can see, it is a similar one, but here you can see USB A port and a USB to serial converter IC. If you notice that header pin designs, these are the pins, this upper side and lower side, and same design is used here also. Another board after these, they have launched another version. It is, I think it is running on same 80 mega 168. It is not clearly visible, but it is also running with 80 mega 168. Uh, so here you can see the most famous Arduino UNO R3. I think many of you have seen in some projects. Arduino UNO. UNO means one in Italian. As they have released the software Arduino IDE 1.0. So to mark the release, they have named this UNO, and this is the most famous board till the date in Arduino history. It is based on different 80 mega 328 PIC, which has 14 digital input-output pins. On upper side, you can see 0 to 13. It is mentioned. those are digital I/O, and uh, or at lower side A0 to A5, those are analog inputs. Uh, and this is having 16 megahertz crystal also to clock this controller at 16 megahertz. If even if there is no capacity, there is no crystal, you can run this controller without on 8 megahertz. And here they have added a smaller IC to program this computer. That I will explain later why it is smaller and what is that. These are the other types of Arduino boards. First one is Arduino Pro. Actually, that is battery operated, a complex size, and for many complex projects it is used. This is the Pro Mini. As you can see, this is much complex than Arduino Pro, as it is not any switch, means not any external pin. Only they have given the through holes where we connect your header pin and use however you want. This is Arduino Mini. Arduino Mini is much compact than Arduino Pro Mini. You can see the difference. Here is one more Arduino Micro. In Arduino Micro, you can see one thing. There is a micro USB port in front. So it is slightly different architecture than earlier ones. It is 20 digital I/O, and uh, among them you can use 12 pins and analog. That controller is different. It is 80 mega 32 U4, which is having inbuilt software USB communication. So you can use this controller as USB hole. There are few projects that the developer has designed a board which interacts with computer or any other system on USB port, just like mouse. The another is Arduino Nano. Arduino Nano is small and breadboard friendly. It is having same function as Arduino UNO, which we have seen earlier. The same function are there in Arduino Nano, but it is having the micro USB B type pin. Mm, this is the Arduino Mega 2560. It has 54 digital I/O. As you can see, the controller is located in middle. Is it 2580 Mega 2560 controller. This is having 54 digital I/Os and 16 analog inputs. So compared to all other boards, this one is having higher I/O capacity. It is having four serial ports. It is called at UART. I will explain you that what is the UART. We will see the later. I think many of you have experience with UART also, but no issue. We can explain later. In earlier boards, there were only one UART, and in 2560 Mega 2560, it is having four UART. UART means it is used for serial communication. If you see here on digital pin number 14 to 19, here it is mentioned that TX, RX, TX, RX, TX, RS. Those are the UART port pins. Uh, if you are having any complex projects or more I/O, you can use this controller or board. This is the Arduino Leonardo. Leonardo is having same architecture as Arduino Uno, but it is having micro USB pin, so it can host for a USB also, USB function. Another one is Arduino Duo. Duo is the Arduino family's first board with Atmel SAM 3X8E ARM controller. This ARM Cortex M3 is not AVR family; it is a different family, and it is 32-bit ARM controller, which is saying same as you can see Arduino Mega 2560. The same architecture you can see in Arduino Duo also. It is also having 54 digital I/O, 12 analog pins, 4 UART, and it runs on 84 megahertz clock. And it is you can see there are two USB ports. So one is used for OTG capable connection. And apart from all other Arduino board, it is having one more facility. It is having inbuilt DAC, digital to analog converter. It means you can generate the analog output from here, and it is having two-wire interface, two ports for two-wire interface. Two-wire interface is much known in the microcontroller world. In your if in your further syllabus, you will get the concept of two-wire interfaces. And just like other controllers, it is having power jack, SPA headers. I will show that what is SPA headers. That is important term for AVR controller. Uh, these two are different varieties of Arduino board. First one is Lilipad. Here you can see Arduino Lilipad. It was designed for e-textile and wearable projects. As you can see, it is not visible in graphic, but this is a flexible PCB based on silicon, and it is having you can use the you can sew this board on your fabric also. On wearable project, it is used, and you can use the same functionality as other Arduino boards. Here, all these out in outer ring is all that I/O connection, and there is a header pin for programming. It is much flexible in any wearable project. You can use the Lilipad. Another one is Arduino Explora. Actually, this board is retired, but it was one of the great boards. It was specially designed as joystick, so it works as USB client, just like we have seen this Arduino Micro, which can interact as soft USB communication. Here also you have put a same micro USB pin. It has onboard joystick, slider. There is slider in middle, joystick, microphone, a buzzer, and sir, okay, it is still 30 minutes, no issue. So on this Arduino Explora, you can even connect the TFT LCD also in middle. But now this board is retired by Arduino, but still you can get it in market. This one is one of the unique board from Arduino family, Arduino Robot, which has two processors on each side of board. You can see there is upper and lower board. Actually, those both boards are actually PCB used as this architecture. And on this PCB, there are two controllers. This board was designed for robotic projects, and it has inbuilt sensors and motor driver board, and it is containing ATmega 32U4. So as a USB host, it can be used. But now this board is retired by Arduino. I don't think it is available in market right now. This is Arduino UNO. This is another type of Arduino board family. It is the same. It is having same architecture as UNO, but the design is different. It is having 18 mega 32U4 and also Atos AR9331. That is the processor which supports Linux distribution. It is based on OpenWRT, then Linux OS. They have developed the OS to run on this Arduino UN board. It has been built on Ethernet. As you can see, it is not the USB, it is an Ethernet port. It has onboard Wi-Fi support. It is having USB slot also, micro SD card, 20 digital I/O, and 12 analog inputs. So if you have to work something on Linux, you can use this board. This one is again Arduino Zero. Arduino Zero is having similar design like I will show you one board. See, in Arduino Duo, there are two USB micro USB ports. Same is with Zero also. In Zero, Zero use maximum for IoT devices, wearable technology, and any automation or robotics project. It is having 32-bit ARM Cortex processor, controller, sorry, and uh, this board is having HTML embedded debugger. Debugging is what that to debugging tool is like you can see what is happening inside our microcontroller or with its code. In earlier boards, that feature is not there, but in this one, that HMS Arduino embedded debugger is available, in which you can see full debug interface without any external hardware. If you use Arduino, by program you can debug the things, but it is not dedicated feature. Here it is a dedicated feature. So recently, within 1 or 2 years, they have developed a new series, Arduino MKR. Arduino MKR, or a few people call it Maker. So Maker boards are compact, very compact in design, but it is having more facilities than earlier boards. Here on first MKR 1000, you can see it has inbuilt Wi-Fi. It is based on ESP32 module. Inbuilt, it is having Wi-Fi. It is having battery connector and micro USB port. So it is compact but having much features. Another is MKR Zero. This board is having audio capabilities. So you can play music files without any external player on this board. Another board is MKR Video 4000. Uh, as it is named, it is used for video application. Uh, you can connect micro HDMI. It is having onboard micro HDMI connector, so you can connect any HDMI displays. It is having Bluetooth and Wi-Fi also. So these boards are very useful for IoT projects. So now, if we come Arduino as product, sorry. So Arduino is open source hardware. Open source means you can copy and use in your project without any payment or fees. These hardware reference designs are distributed under this license, which is mentioned that Creative Commons Attribution Share Alike 2.5 license, which is available on Arduino website. So under this license, you can use or copy this architecture in your design. There will no charge for that. Although the hardware software designs are freely available under license, the developer has requested the name Arduino to be exclusive to the official product and not to be used for derived work without permission. So there are many Arduino compatible commercial release have in market, but they will they will don't name as Arduino. They will just name something like Arduino, Tiny Arduino, Robot Time. So they will have same architecture, but they will not use the same word Arduino for their design. Now we will come on bootloader. So what is bootloader? Uh, if you take any AVR microcontroller, that bootloader is a little program. So it is like when you turn on the Arduino or Arduino on and press the reset button, it will run the bootloader program first. That Arduino bootloader program, the main function is to wait for the Arduino software on your computer to send it a new program for Arduino, which is writes in memory on the Arduino. So bootloader is the program, just like when you reset the Arduino, first it will run the bootloader and then it will run its own code which we have programmed. That bootloader is important because normally you need a special device to program Arduino. That bootloader enables you to program Arduino using just USB cable or any other communication media. The bootloader is just like BIOS in your computer. If you are having not a BIOS installed in our motherboard, you can't run anything or any OS on computer. Same with Arduino. If you are not having bootloader program in that, you cannot use that. Arduino microcontrollers are usually pre-programmed with specific bootloader. and that simplifies uploading a program to onboard on-chip flash memory. Uh, in Arduino UNO, the default bootloader is OptiBoot bootloader. That OptiBoot bootloader they have termed the Arduino designers they have termed it as OptiBoot bootloader. So here you can see by two different methods we can program the Arduino boards. Right now, almost all Arduino boards are having USB capabilities, and it is having inbuilt USB to serial chip. So you can see here on left diagram, there is FTDI USB to serial conversion. And the USB to serial conversion NFC chips, these are FTDI CP2102 are the types of that USB to serial. And in Arduino Uno, there is the dedicated FTDI. FTDI means for the terms are used for USB to serial conversion. They are having dedicated chip on that board. Yeah, it is usually 80 mega 8 or 80 mega 16. So these two are ICs which are used as USB to serial. They have those ICs are inbuilt program for USB to serial firmware. So uh, if I see the earlier slide, here you can see there is a small IC. I'm not. It is capable for Zoom. I think up to this level only. Here there is a small IC. It is 80 mega 16 UT. This IC is having inbuilt firmware which enable to connect this AVR with USB. So it is having inbuilt USB to serial firmware, which help us to program the Arduino board using the software. And another thing is ICSP header. On in any AVR, there will be ICSP header which is used to program directly on IC. If you are not having any USB to serial controller, you can directly program this AVR microcontroller using these SPA ports. I will show you uh, what it looks like. Here on Arduino board, you can uh, see in this design, you can see here. Here is the ICSP header. It is written below. In this one also, in Uno, there is here and an upper side also. In this mini and pro mini boards, it is not. In micro, it is there, and nano, it is there. On Mega is also there. You can directly program this 80 Mega 2560 using this ICSP header. Whatever doubts you're having, you just note down in paper, and we will have some question answer session also. So now we'll start with Arduino Uno. This is the most famous. Why I'm suggesting this? Because it is having simple architecture and most common design, and lots of fields are available for Arduino Uno. In Arduino Uno, the main microcontroller is ATmega328. It operates on 5 volt, and it can sustain up to 7 to 12 volt. But though we have to maintain the 5 volt DC for a better performance. It has digital input output pins, 14 digital input output pins, and 6 are having PWM, pulse width modulation output. As you can see, it can be configured for both digital input and output. So for output, there is one more feature that we can use it as PWM, pulse width modulation also. I think many of you have heard this term, pulse width modulation, and soon it will be there in your further microcontroller syllabus. It has 6 analog pins, which was in marked as A0 to A5 in earlier this board. The DC per current IO consumption is 14 milliamp, 40 milliamp, and for 3.3 volt pin it is 50 milliamp. It is having flash memory of 32 KB. Flash memory, its total size is 32 KB, and it is a 8-bit controller. That's why they have named it 80 mega 328. As you can see in name, 32 means 32 KB, 8 means 8 bit. And out of the 32 KB, 0.5 KB will be used by bootloader. As we discussed the bootloader here, that bootloader itself a program, so it will contain certain variables. So it will consume 0.5 KB. It is around 500 bytes. In total flash memory 32 KB. It is having SRAM of 2 KB and EEPROM of 1 KB. In EEPROM, you can store your values. So even if you turn off the controller or completely power off the controller, the values will be stored in EEPROM. So in EEPROM, we are having 1 KB size. Usually for Arduino, some small level projects, it is sufficient. When you will use in your day-to-day project, I think it will almost be sufficient. But if it is not sufficient by you, you can get up to 1024 KB EEPROM in market, which is external. You can connect it with this 80 mega 328 controller. This controller is having inbuilt 8 mega oscillator, crystal oscillator. So without any external crystal, it can run. There is no issue. And many projects are running on 8 megahertz without any issue. There is no issue. But if you want higher clock speed, then you can use external oscillator of 6 megahertz, up to 6 megahertz. So here is the Arduino UNO pinout. Uh, in pinout, there are different functions are mentioned, that digital pins 0 to 7. If you see this side, uh, you can see digital pins. It is marked on board from 0 to 7 and 8 to 13, and there is a ground pin. So 0, 1, 2, 3, these are the digital pin numbers, and pin number 0 and 1 is for inbuilt UART. It is having onboard UART, one UART. It is used for serial communication with 80 mega 328 IC. On left side, you can see analog pin. So analog pins are used for analog input only in our case. In this Arduino UNO board, it is only capable for analog input, but in other design we have seen earlier in presentation, one or two boards is having analog output facility also. Uh, on upper side, there are the voltage pins for 5 volt ground. You can we can see the power distribution in this slide. Here you can use the external power supply, 7 to 12 volt DC. Uh, Let me show you the board I'm already having. So upper side there is a power supply, USB connection, voltage pin. Uh, there are there are pins I have mentioned, that A02 if analog pins, digital pins. So each of the 14 digital pins can be used for input or output both. There are the software functions like pin mode, digital write, digital read. These are the software functions which I will show you later in actual software of Arduino. That's how we can program. We will try the programming session also in this. This digital IO pin operates on 5 volts, and each one can receive up to 40 milliamp. And they are having internal pull-up registers also. First of all, we see the serial pin. The pin number 0 and pin number 1. RX means receiving, T means transmitting. So they work on TTL, transistor serial logic. That is a different term you will learn in microcontroller subject. That TTL and CMOS, two types of voltage level we use in microcontroller. So these pins works on TTL. These pins are connected with uh, pins of 80 mega 8U USB to serial chip. So as we can see here, Uh, there is 80 mega 16U pin IC, which is directly connected to the USB port, and same is connected to 0 and 1 pin also. So that chip is nothing but USB to serial enabler for this board. So this 0 and 1 pin are directly connected with our UNO board. So as I said earlier, when you start or restart the Arduino board, first it will run the bootloader. The bootloader program will check if any incoming program is there or not. At that time, these two pins 0 and 1 will be in use or by this 80 mega 8 UT USB to TTL serial chip. So if you are using these pins for any hardware, you have to disconnect while the board is starting or restarting. There are the external interrupt pin number 2 and 3. Interrupt, that term is used in microcontroller for the priority of detection of pins. The term you can, I think you have studied. Sir, interrupt term is already there in microcontroller. Hello, Rakesh sir.
Yes, sir. Yes. Interrupt is clear
Oh,
in fourth semester students.
okay. So
But you can give one or two
interrupt.
example of interrupt.
Okay, we'll see that if it is possible in this session. We'll see that. No issue. Uh, Interrupt pins are at pin number 2 and 3. Pin number 3, 5, 6, 9, 10, 11. These are the PWM, pulse with modulation. Here, pulse width modulation, I think you have seen that you can use this digital pin, but with variable output. It is used for usually, uh, for example, if you want to dim any LED connected to this digital output pin, if you use digital state 1 or 0, either it will be on or it will be off. But you change the intensity of brightness, you can see the PWM feature. Though the pin is digital, but still you can use it as analog write function. So analog, why it is used that it it somehow it acts as analog output configuration for this using this PWM. Next is SPI. So SPI, what I have shown is here, this one. In this, you can see there are the pins like MISO, STK, REF, MOSI, and GND means ground, VTG means voltage. And same thing is available on Arduino boards also. Here you can see ICSP header. So ST pin, pin number 10, 11, 12, 13. This pin supports SP communication really, which is in all AVR in all controllers of AVR family, you will find these pins. Though the pin number will different, but you will surely find this MOCI, MISO, MOSI, MISO, STK, and SS pins. So you can directly program the controller without any USB to serial pin. But yes, you required a special programmer for that. If you want to program using SPI, yet the different type of programmers are available. That I will show you. Arduino is having inbuilt LED connected to digital pin number 13. Why this LED is given on pin number 13? Then if you want to present any onboard indication at certain function or certain condition in program, you can use this onboard LED. You even if there is only one LED, but you can connect any of pin digital pin with LED as per your convenience. But this is the onboard LED, so it will be somehow useful in many applications. Once you start to using this, you will get how useful it is. It is having 6 analog inputs. In 6 analog input pin, each pin is having 10 bit of resolution. So if you start from 0 to 5 volt on this pin, if you are feeding from 0 to 5 volt, the count will vary from 0 to 1023. Actually, I have uh, given 102 for different values, but it will start for with 0. So it will give you for with 1023. So for 0 volt, that pin reading will show 0. At 5 volt, it will show 1023. Uh, by default, it is scale for 0 to 5 volt, but if you want to change the scale, like for example, you want to measure 0 to 3 volt, there is analog reference pin. Uh, Here I have mentioned analog reference pin. That analog reference pin is unable to this 0 to 5 volt scale. If you are having any dedicated sensor or any circuit where you have to measure 0 to 3 volt in span of 0 to 1023 count, you can change the voltage at analog reference pin. By default, it will be 5 volt, but you can change from analog reference pin or using this analog reference function. The next one is I2C or I square C or IIC. I think you fourth semester students may have studied this I2C protocol. So here in this controller also we can get the I2C pin, that is S data and S clock. S data is on A4 analog 4 number pin, and on A5 you can use it as STL serial clock. And this one use wire library in our program. Wire is a good communication protocol, or there is a two-wire protocol. So in two wire, you can parallelly connect multiple I2C devices. There will be a clock module or some LCDs or some sensors which we are having I2C communication method. So only using two pins, you can connect multiple sensors. So the pin numbers will be saved, and you will get maximum data from that. You can connect up to uh, 128 devices if you are using 7-bit addressing. So we are having multiple devices on I2C bus, and each one should have different address. Otherwise, that both of two will not work properly. Each one should have different address. So if our addressing is up to 7-bit, then we can use 128. If our addressing is 10-bit, up to 10-bit, it can be used as 1024 devices. So on only these two pins, A4 and A5, you can you can use multiple devices on same pin. Here you can see that ICSP header. ICSP stands for in-circuit serial programming, and the pin diagram is also shown that MISO, STK, reset, VCC, MOSI, and ground. Uh, Voltage and ground are common voltage and ground for microcontroller. The pin number 1 of this microcontroller is reset pin, and there are two ICSP header on Arduino UNO board. Here is the memory map. As you can see, there is a program memory, data memory, and EEPROM. Uh, Program memory, you can see that uh, in enter program memory, it is total 32 bit, but boot flash, that bootloader portion will consume some part. It is approx 0.5 KB. In data memory, there are just like 805 controller, you may have familiar with this term with registers. So similar registers are there: 32 bit general purpose register, 64 IO registers, IO extension registers, and SRAM. So this is the memory map just for your reference. Uh, in practical, these terms will be different while you are using. Uh, it is in software. When you compile the program, it will show that how much memory it will consume. That we'll see in Arduino IDE software session. Now, the communication part. So when we start using Arduino, first thing is we have to load the program in it. So it has a number of facilities like you can use on serial or ICSP or using these such ICs. So that 18 mega, 8U2 and 16U2 are the onboard channels which enables serial communication over USB. So when you connect this Arduino board with your computer, it will show as a virtual comport. I'm not sure if you are aware about comport or not, but in an earlier design of computers, you still you can see that there were COM ports, serial communication ports with DB9 connector. In nowadays, in maximum designs, there is not available. So this programming, this firmware of 80 mega, 16 UT and 8 UT ICs are designed as it will detect as virtual COM port on computer. So whatever the software which is using COM port can be connected with our serial communication, even if it is not having the physical DB9 connector serial COM port. We can use this as virtual COM port. This Arduino ID software, which is used to program the Arduino board, it includes serial monitor also. So you can use the directly serial command to Arduino board, and it has RX and TX onboard LEDs. So whenever there is any data on TX channel or RX channel, the LED will flash. So whenever you're programming or you are using any serial communication, you can check if this communication is happening or not. You can see this LED is blinking while the data transfer from through. Even if it is having onboard serial port for P0 and 1, you can add more serial ports by using software serial library. So you can use other digital pins as software serial. Like you can use other UART devices or sensors on same Arduino. For example, if I am having two serial devices which need to be connected with Arduino UNO, you can connect this pin number 2, 3 as a serial port, software serial port, and pin number 10 or 11 as another serial port. You can you can get data from any of serial devices connected to this pin. Uh, but at a one in program at one time you can access one device. So for example, device A is connected to pin 2 and 3 via serial UART, and device B is connected to pin number 10 and 11. So if you want to get data from pin number 2 and 3, in program you have to enable software serial for 2 and 3 to get the data from that. Then you close the software serial for pin number 2 and 3. You enable the pin number 10 and 11 for another software data from another module, a serial module, and you have to disable again to use the pin number 2 and 3. So simultaneously it will work. It will not work at a time. If you are using multiple software serials, you have to call any one software serial at a time in program. So Arduino IDE is the software from where you can program this Arduino. I will show you just a minute. You can see here in start menu that Arduino software is there, first one with Arduino logo. If I click that, leave it will take some time to get started. So this is the Arduino IDE software. Here you can check that right now that version is mentioned here. Wait, the version is 1.8.12. The latest version is 1.8 to 8.12. Here you can see it is written that an open project written, debugged, and supported by Arduino CC. Arduino.cc is their website, and the Arduino community worldwide. So they have prepared this software for open project writing, debugging, and it is supported by Arduino. That is a worldwide community. As you can see, if you go to any engineering college or any work who is working with embedded, you will see that Arduino term. Almost people will be familiar with that. Here in this board, wait a minute, wait. You can run this software on Mac, Linux, and Windows. So here you can see uh, in tool menu you can select the various boards. There are lots of boards which are available in market. You can see I have selected Arduino UNO, then Dicimlia and Nano, Arduino Mega, Leonardo, Arduino Micro, Explora, Mini, Ethernet. There are a few boards like Arduino BT, Bluetooth, Arduino Pro Mini, Arduino Robot, and this 82 ESP8266 board. That is a different controller family. That these can be programmed for from Arduino IDE also. These ESP8266 are Wi-Fi enabled board. So in IoT projects it is used widely. But here we will see Arduino Uno. Uh, Once you connect this Arduino Uno, the port will be there. As I said earlier, it your Arduino Uno will be connected as virtual COM port. So I will show you. Uh, just give me 1 minute. I will show you. As you can see, if you can you see my camera? Another camera? Is it visible?
Yes, sir.
So here I am having an Arduino board. So I will connect that. This is the serial cable. Wait, it is that normal USB cable. Sorry, USB A type cable is there. Uh, I will connect it with my laptop. As you can see, the LED is blinking on that. That LED is connected with pin number 13. So once I have connected this Arduino, it will be visible in port as COM port 9. In presentation, you can see the port on port it is available as COM port 9. I will select that COM port. The programmer we have to keep it as AVR ISP. There are different types of programmer boards also, but here we have to use AVR ISP. Uh, we will take one example of LED blinking. Right now, this LED is blinking at interval of 1 second. 1 second for on, 1 second for off. So in presentation, you can see there is a code. This window is code window. Here you can program. So all of you have studied the C and C++. The same thing you have to use in this. So it will be much easy for you to program.
Mr. Sanjay, you are not audible.
Now am I audible?
Ah, yeah.
Okay. So can you see this programming window?
Yes, yes.
So here we have to use C++ programming syntax. There will be two loops: void setup, this is the first loop, and another is void loop. Void setup is what which will run in starting of program after, obviously after bootloader. First, it will start the setup loop. So whatever the configuration of pins or any library or any module that you have to do in void setup. In void setup, the most basic necessary thing is a setup which used to run this entire programming loop. So what we have done is we have configured a pin as output. The pin name, the pin mode we have configured. Here you can see the pin mode. What pin mode we have to configure. The pin number you have to mention here. It is mentioned as LED underscore built-in because on pin number 13, the LED is connected. So in this board, either you write LED underscore built-in, or you can simply write pin number 13. So pin number 13 will be configured as output. In this statement, it is written. So loop starts here and ends here. These are the comments. By this double slash, you can give the comment in between the program. In loop function will run continuously. So in loop function, we have mentioned the digital write. So you have to write a digital pin, mm, which is the pin number that we can write here, 13. And what we have to write, high means one state or high state. And later on there will be a delay. So delay, it is in milliseconds. So for 1 second I have given 1000. Here by default, if you can see on board is blinking on 1 second delay. We will take it on 500. So half a second of delay for high status. So once we write the high on pin number 13, LED will on. For this delay, it will keep it on. In next line, we have written digital write LED. Let we will change this pin number also. Digital write and low. So it will turn off the LED because we have given the low signal, which means 0. So high or low. We are using this as digital output pin. So high or low will work. And delay I have set as 500. So for 0.5 second it will be on, and for 5 seconds it will be off. So here on top side, if you can see, there is a small tick mark button that is for verify, or you can see compile. You can compile enter program, either it is having any syntax error or what. Once we press this, it will start to compile this sketch. The sketch means the code what you have written in Arduino IDE software. It is used as terms as sketch. So here in output window, as I said earlier, it shows that sketch, the code we have written, uses 924 bytes of, it is around 2% of program storage space. Maximum is 32256, 32 KB bytes you can use. So out of 32 KB, it is using only 2 KB. This program is using only 2 KB. The global variables uses 9 bytes, 0% of dynamic memory, and leaving 2039 bytes for local variable. Maximum is 2048 bytes. So in some cases, in program you have to use the global variable. We are having the limit of 2048 bytes, but we are using only hardly 9 bytes, so it will not affect much. So now once our program has been compiled, here you can see the message done compiling. If I am having any syntax error, for example, let's create any error, I will remove one semicolon, this semicolon from program, and will compile again. So uh, here in output window, you can see it is giving error. The expected uh, this semicolon before this token. So it is telling that before this where loops the end, here you have to use semicolon. So if you are having any syntax error, it will show in this output window. Or if you are having any library error, library I will explain later, that this is a simple LED on off. But if you are using any module or any external sensor, you may have to use the library. Library is nothing but a program written to access this module easily. In code, you can use that sensor values easily. For that, libraries are written. For different module, different libraries are there. So here I will put the semicolon again and I will load. Here is the upload button. From here you can upload the program from your computer to Arduino IDE. So during this you can see, okay, it is it was tweak and it is showing done uploading. So now you can see, wait a minute, the LED blinking in camera, you can see LED blinking timing has shortened. So it is blinking faster than earlier. Can you see the difference? Can you see the difference of earlier and this one? On camera, I have focused that LED. It is blinking faster than earlier. So what I can do, I can make it more faster by decreasing the delay. Instead of 500, I will take 200. So, see, now it is blinking faster. Have you noticed the difference of earlier and this one? Anyone?
Yes. Yes, sir.
Okay. So this is a simple example of how you can turn on the and turn off the LED with this delay. If you want to flash the LED at every 1 second, I will change this delay. Off delay I will keep as 950 and on delay I will keep as 50. One thing I will tell you that beside this onboard LED, there are two more LEDs, TX and RX. So when I will give upload, you can see those LEDs blinking. As I told you earlier, these two TX RX are directly connected with that USB to serial chip. So whenever we have anything on serial, it will blink. So you keep notice, once I give this upload, those two LED will blink because it is transmitting and receiving from microcontroller to microcontroller. See, now it is blinked. Okay. So now you can see it blinks at interval of 1 second. I think due to this streaming, you may feel a little bit different, but actually in practical, it is blinking at every 1 second. So this was a simple example that how easy to program your Arduino Uno board. You can see there is no more setup, only a USB, USB cable which is connected to Arduino Uno USB port, and so using this simple thing you can program your Arduino Uno board. This was a simple example for LED, but if you go in actual applications, there will be lots of things like LCD displays, sensors, different types of modules, and the term I used shield. What is shield? Shield are modules which are easy to mount on this Arduino Uno board. I will show you. I am having one shield. I am having one sensor shield. In sensor shield, it is nothing but simple I/O assignment. Digital pins, analog pins. Those are from analog Arduino Uno board, which are simplified. So if you want to multiple sensors and to work with Arduino Uno board, you can use such a shield. I will show you. It is having the same pin design as Arduino Uno, so I can easily mount on this Arduino Uno board. As you can see, shield is mounted. That shield is also having the onboard same LED of pin number 13. This shield is mostly used when you are starting with Arduino Uno and you want to interface various sensors. You can use this shield. It is having onboard easily configuration pin, 5 volt ground, then analog I/O for serial communication, for Bluetooth modules, for LCD. The pins are simplified here. So there are various types of shield. I am having one more shield. That is Ethernet shield. If you want to enable Ethernet communication with Arduino Uno, you can use this shield. Here you can see that Ethernet port is there, and one micro SD port, micro SD card slot is also there. So you can let me show you. Here you can see it is easily stackable on. Wait a minute. Mm. So now that Ethernet shield is connected on Arduino Uno, and once you start with any project with Ethernet, uh, this IC, there is a IC on shield is there. So it will communicate with our ATmega 328 and will give correspondent feature on this Ethernet port. So if in your project, if you want the LAN capacities, you can use this shield for Ethernet Arduino. For different type of board, different designs of shield will be there. For Arduino Uno, maximum shields are available. For Nano and other things, there are not much easily available shields are there. Uno is the most famous design. That's why there are lots of shields. One more shield I am having, that is LCD and keypad shield. This is having 16:2 character LCD and keypad. So both are combined in one shield, and easily we can use this LCD and keypad, which is Arduino Uno. So one more thing I will show you, this shield. This shield called as uh, Arduino bootloader shield. Uh, Let me come back to on bootloader again. Uh, for AVR, this 80 mega 328 IC, which is AVR, if you want to program, either you can directly program your software in their own HTML's own HTML Studio is there, where you can write the program. So another software is also there, that Micro C, that also enables to program AVR. So if you are using Arduino IDE, your IC 80 mega 328 should be having loaded with Arduino bootloader, OptiBoot. We have seen in earlier last screen that bootloader, Arduino bootloader should be there. If that IC is having Arduino bootloader, then only it will be capable to program. So sometimes it happens that if you purchase 80 mega 328 from market, it is not having bootloader loaded. So in that case, we can use such a shield. Then we can use one Arduino UNO board as a programmer of individual IC. Bootload. To bootload one IC in market, maximum ICs are is having Arduino bootloader in 80 mega 328, but sometime in few manufacturer will not bootload in that. So in that case, uh, we can do we can say use this shield. Simply, this is a simple connector. Uh, you can put your microcontroller, lock it, and there is a sequence of method to bootload this IC using existing Arduino UNO board. So once it is bootloaded, you can use this IC in any Arduino UNO board to program, or you can uh, see in same board. For example, I will show this IC is removable, stackable. It is DIP package. So in DIP package, you can remove. There is a socket also. So while using any project or any experiment, if your IC is damaged, for example, any high voltage or pin or any higher voltage in operating voltage, if this controller gets damaged, you can simply replace this IC and you can use another bootloaded IC on that place. So it will be much easy. Even if that IC is having fault, microcontroller is having fault, you can replace this. There is no issue. So this is also an important shield. So these shields make our things easy to make any prototype. If you want to design something, so first you will go for prototype. So in prototype, you can use such a shield. See, in presentation now you can see, I have explained this LCD shield. It allows to interact Arduino Uno with LCD module, 16 by 2 LCD, and uh, these keys also for any simple program or menu design. You can design a menu also in this LCD. Some of libraries and coding. These are sensor shield which I have shown you. It is a low cost board and but much easy and convenient pins. In PPT you can see, presentation you can see, the digital pins are given in sequence with each pin is having voltage, ground and signal. S means signal, this is which is directly our digital pin. V means it will give 5 volt. All V pins will give 5 volt. All G pins ground voltage is connected. So if you want to connect multiple sensors, there is easy interface for you. So if you are new to Arduino Uno and want to connect multiple sensors, this shield will be easy. Here analog ports are there, A0 to A5. For that also it is given. For serial communication, that TX-RX is given. For I2C, IC or I2C, that different port is there. And apart from all of these, you can get the external power connector. If you want to power up this Arduino externally using 5 volts, the screw terminals are also there. The reset button, same reset button on Arduino Uno board, the same functionality will do this. And we have onboard LED here also. So it is directly connected to pin number 13. So this is the easy sensor shield. Uh, Next is this prototype shield. On left side you can see the simple shield. It is nothing but this is header piece which is connected to Arduino UNO, and there is a small breadboard design. It is nothing but if you want to connect multiple components as per your convenience, there is a small space is given as breadboard. You can connect this IO as per your convenience. Just like you small add-on circuit you can add here. It is up to you that how you are using. Another one is motor driver shield. Motor driver is usually for robotics application or any motor driven application. Motor driven shield can be used. Why we need external motor driver shield? Because as we have seen, the digital IO pin consumption will be in 40 milliamp, but in case of motors, it will consume high. So we are having separate driver ICs for motor, which we are mounted on, which are mounted on this shield, and the motor connections are also there. So it will not use the power from Arduino digital IO pin. You can give separate power for motor, power in and power out for motor. These ICs will simply get the command from Arduino UNO and will run the motor accordingly. You can turn on and turn off the motor. Also, you can increase or decrease the speed of motor using such shield. You can design your own circuit using similar ICs and on PCB also. Here there is a real-time clock shield. Means why it is used is uh, in some applications you will use clock. For example, if I have designed a clock with UNO, once I will power off, it will not run the clock. So what I will do, I will externally add the clock. Right now it is shown a shield here. So it is small power socket here. Button cell will be there. So what button cell will be do? There is small IC near my button cell. That is a clock IC. What it will do? It will just continuously run this clock inside that using this button cell. And this configuration of RTC consumes very low power, so it can run for days or months. In some, if you are having higher power, not a battery but more battery, then it can run on months also. So it doesn't matter you turn on or turn off your art project or enter board anytime. Whenever you start again, it will give the exact clock. Just like in our phone, we turn off and turn on. Our phone is having internal inbuilt battery for clock. The same thing will be here also. You can retrieve the time. Time will be retentive here. But in this artificial, they give this SD card slot also. In case if you want to save any data in SD card. Yes, you can write anything on SD card. You can make a text file or CSV file using Arduino UNO program, and you can save the data in SD card also. The next is relay shield. In relay shield, you can see there are 4 relays mounted. Relay shield is used for device on off, controlling devices for any simple robotic application, or any if you are making any personal project to do turn on turn off devices as per your requirement. You can use such a shield. Here is the Ethernet shield that I have mentioned, that I have shown you. Another one is RS485 shield. This is a really interesting one because it enables the RS485 communication. So you can enable the Modbus communication using Arduino UNO. If you program 2 Arduino board, one is master and one is slave with these shields, you can communicate 2 Arduino boards on Modbus using this. So next one, GSM shield. So it is much widely used. You can enable the GSM connectivity with Arduino Uno. It will have GSM module, antenna, a separate power pin will be there because GSM module will consume minimum 1 ampere at peak. When you start a GSM module, it will consume 1 ampere. So at that time, your Arduino Uno board might not be stable. So for that one, that external power socket is given on that, and that microphone and speaker jacks are also available there. Another is GPS shield. Here in this, the small GPS module, GPS receiver, we can say GPS satellite receiver is there. It is small and works on UART. On simply TXRS, it gives the data. This is the simplest but yet powerful module. Uh, it is one single GPS module. GPS receiver can give you location, your speed of movement. If you are moving with the GPS receiver, it will give you speed, your local time, UTC time, all things one module will give you. So this is a much interesting one. This one is also having shield, and this battery is given to make the GPS shield data retentive. If you don't, if you completely power off, during power on, GPS will consume much time to get the satellite initially. See, here I am having one GPS receiver. In camera, you can see there is a small GPS receiver I have given. This is small inside. You can compare with my fingers. It's very small, and only four pins are there: positive, negative, TX, and RX. If I enable this, it will give the location and current. It will give all the details in GPS terms, like how many satellites are connected, and few of digital terms are used for satellite, uh, which we don't generally not use. But here you can get location, speed, and all of these things. These are the modules, sensors, or you can say modules. There are varieties of modules. I'm not sure if names are visible or not, but you can see joystick module, relay module, this sound module. It is having microphone on. This is another small sound module, which it is a small microphone. Then this is the IR obstacle detection. It is an IR transmitter and receiver. So if you are making any robot, you can use this module. Uh, Buzzer, then a rotary encoder, flame detector is there. You can use this flame detector with Arduino, and you can make flame detector using that. That Hall sensor to detect magnetic field. This is metal touch sensor. This is thermocouple module. They have mentioned as digital temperature. Then RGB LED is there. RGB LED you can give red, green, and blue values, and you can get whatever color you want. You can give any hex value to this pin using Arduino. You can get any color. Then two color LED, shock sensor is there. Yes, if you want to make any accident detection, then you can use this shock sensor. Laser emission, laser module is also there. You can, if you want to use any laser detection or laser emission, you can use this. Heartbeat module, there is one heartbeat module is also there. Then tilt switch. If you want to measure tilt alignment of your if you want to detect any tilt alignment in your project, you can use tilt switch. Photoregister, nothing but an LDR. This temperature and humidity sensor. So there are lots of sensors are there. Here are some special of modules. Serial MPC player module. So how it looks, serial MPC module is, just wait a minute, I will show you. Uh, I was having one serial module. Wait a minute. See, I just opened the pack. If you can see, there is a small micro SD card slot on that, where you have to store your MP3 files. In micro SD, you just save your MP3 files. In another side, you can see that serial pins. There are nothing but voltage, ground, TX and RX. And this is the audio output pin. Here you can connect any output speaker or hands-free or whatever you want to connect. So by giving commands on serial, you can play any file, play, pause any file you can access using this module. So like that, you can see in presentation, RTC modules are there. Micro SD card adapter. If you want to write something in text or CSV file, you can use this module. The 4-digit display module, expansion shield, buzzer, then rotary encoder. It is same as earlier. Light sensor, touch sensor is there. This rain water sensor. If you want water pressure sensor, you can use this. So different types of sensors and modules are there. Then there are LCDs are there. Color LCDs, monochrome LCDs, and in LCDs also there are types: TFT LCD, OLED. So here you can see there is one TFT LCD which is having touch enabled display. It is color touch enabled. So you can write by touching it. This programming you have to make proper in our Arduino IDE. There are libraries for that. By that you can configure, make your program. There are examples also. If you have purchased the module, I mean, if you want to taste it, there are ready-made examples. You just connect it with Arduino and you can taste how it is working. See here, there is one project uh, for alignment of surface. In LCD, you can see that the leveler. So if there is one more sensor, that the sensor is there, the gyro sensor is there. Accordingly, it will show the level of that board in LCD. So yet it has used Arduino Nano, one that module, gyro module, and LCD. So using this component, the simple configuration, and we can make this. Here there is OLED. In OLED is really good for in sunlight you can see it easily. At night it is much comfortable with our eyes, and you have seen that OLED in our wristband also. Smart bands are there. In that also OLED is used. So in OLED you can configure various graphics, and you can display whatever you want. In such a library example, they have displayed 3D objects also. If you want to display any bitmap image, you can show the bitmap image also. Here one user have prepared a Tetris game, the old Tetris game we have played, using this Arduino UNO, that OLED, and one joystick module. The simple component, but he have worked hard for his programming. So using this simple component, he has designed a game, Tetris game. Uh, See, uh, if you are using UNO for prototype and testing, okay. But you can run this microcontroller without any special configuration, but like this simple configuration, you can run this IC on your own PCB. Simple, you have to give this component, like first is 10 register to reset pin, a simple 10 microfarad capacitor in voltage and ground pin, this 16 megahertz crystal, and 222 PF capacitor. Using this simple configuration, you can run this IC. If you have programmed something in IC and you put it in this configuration, it will run without any issue. You can make any of project. You don't have to use any board, Arduino board. You can just take simple general PCB, put this IC, and you can run. There is no issue. Just a minute. So So this is a bare minimum configuration. If you Google, you will get bare minimum configuration in Arduino. So this is a simple configuration and used in many applications. For at home, you if you want to design any application like Bluetooth control or Wi-Fi control, anything, a simple configuration you can do, and it will run without any issue. And this IC really robust, and there is for our atmosphere there is no issue with weather also. So we are not having such a high and low temperature in our region, so there is no issue with that. It will run easily. You can program this bare minimum configuration using this one Arduino. As I said, you can program one 80 mega 328 using another Arduino Uno. You have to just connect it on ICSP pin. You can see serial clock, MISO, MOSI pin, then reset pin. Only you have to connect these four pins, and you have to make this Arduino Uno board as a programmer. There is a in Arduino Uno. I will show you. There is one thing uh, in example. If you see, there is one example Arduino ISP. If I load this code in my Arduino Uno, it will work as Arduino ISP. Or one thing, if you remove this IC from board, you can program this bare minimum configuration directly by downloading program to this board. You have to remove this IC and connect this configuration. You can directly program this IC. So if you want to make your own board, you have multiple ways. Either you connectize this or you put the IC in your Arduino Uno board, you're programming and remove it and you plug it on your board. So it will look good for a project presentation. For see, this one is important for students. For prototyping, there is no issue. Prototyping, you can connect whatever you want to connect board, ready-made board you want to use. Like here, you have to use ready-made Uno board, this fan or any module. But when you are making any final project or any tech event project, avoid using this ready-made board. You can design your own board like this, as I have seen in presentation. Wait, it is loading or not? It is loaded. Here you can see on PCB 80 mega 328. 328 is used separately. It has not connected the crystal also, so it is working fine on 8 megahertz. It is connected with 7-segment display, one RTC module on left, one buzzer, and the power one. So this simple configuration works really good when you are having presenting your project. If you are presenting your project ready-made with Arduino Uno, and it will not give much impact, but such a configuration will look like you have really worked hard on software side also, hardware side also. Sorry. So you try to make such a devices. Onboard, you can design your onboard PCBs. I have designed one thing. If you see in camera, wait a minute. See, this board. This is the simple Arduino minimum configuration that I have designed, and PCB also designed by me at home. This was my first experiment in PCB designing. So you can see some wires because I have missed some connection in designing, but still it works very really fine. Here I have used the external crystal also, on board for voltage regulator 7805, some header pins, programming pins, and 5-volt pins. So I can use this board in some of my testings also. There is no issue. So you can also design your board like this. So uh, this is how Arduino Uno is being used, but how you can use in your project. So doubts and queries, participants. I think few participants were angry.
Now, students are requested to, if you have any query, you can ask and you can unmute yourself and ask the
You
questions.
can ask any query. Don't afraid. You can ask anything. Anything. Even if you are having single doubt, you can ask anything. I will explain. Anyone? They are afraid of you are being here or what? They are not asking. No queries? Oh, they have learned faster than.
Okay, fine. I think they got some idea how we can use Arduino board in real environment, and that one is very different concept. You have explained very well how we can use Arduino IC alone in various project work. That part is very important for our student, because our students are always using directly Arduino board, and that is not good sign. Even many our examiner also told we are not
Yes,
going to
that is not good
allow
thing.
Arduino board in the project work. So I think that part is very important. Okay, so here, Mr. Sanjay Mistry, we are very thankful on behalf of Instrumentation and Control Engineering Department, and you have provided
Thank you,
such
sir,
a good
for allowing me for this.
experience. Yeah, definitely. And you have explained all the things of Arduino board, as well as some shields, as well as how we can write the code inside the Arduino board. We are very thankful to you. Even we are very thankful to all our
And
participants.
you can see in camera there is one small board. 80 it runs on 80 mega 168. That is really small one. That Arduino Nano. I am having Arduino Nano is also. Then here there is one more board that I will show ESP8266. That is a different thing. It can be programmed through Arduino IDE, but it is having Wi-Fi capabilities. So in future we will try to set up one session for that also. But till now I can explain this Arduino. There are such shields. I will show you some of the shield modules. It will just take 5 minutes. There is a keypad. You can interface the keypad. Then there is one gas sensor. Simple gas sensors. There are different categories in that. You can measure various gas in air atmosphere. Then ultrasonic module. You can measure the distance with some object. So here I am having this such a lots of boards. This RF communication is there. You can communicate up to 1000 meter in open field. This is a Bluetooth communication. So simply you can add Bluetooth capabilities with your Arduino. And there are lots of boards. If any student is interested in to learn further, you can contact me directly. I will show you how to connect this one. This is the motion sensor I am having. So there are lots of sensors and modules which we can interface with this. But I recommend that you don't use it with Arduino Uno. You make your own board. Okay, sir.
Yes, Mr. Sanjay, now you have explained all the things very well, and I would like to share two things with you as well as students, because we have a 36 modules available in the department for interfacing with the Arduino, and we have a more than 10
In our
Arduino
lab.
board in the department. Yeah, we in our laboratory. Even we have a Node MCU as well as Arduino Mega and Raspberry Pi also available in the department. Okay, and here I would like to share one more thing, because we are suffering from the corona pandemic. Government have taken, even I have read one article from the Canada. The Canada government wants to develop ventilator using Arduino board, because they are not able to provide sophisticated ventilators to all the patients. So they requested to university and college, they provide a prototype ventilator using Arduino board, and provide the facility for the patient. So I think we can use this type of board to develop ventilator and other application of
Your
these
voice is breaking.
situations.
Okay.
Uh, 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 Everybody is listening me properly?
Yes, yes. Now available.
Yeah. So I think
Yes,
we
sir.
have to take this. We have to try to use this board to develop one application and understood how we can use this board to use in real-time applications. So we are very thankful to Sanjay Mistry and behalf of SVIT. And if still we have any question or any
Thank you so
question,
much.
Dhruv sir, do you want to ask something?
No, sir. The overall the webinar is very good.
Huh.
Mr. Sanjay sir provides a lot of knowledge regarding SILD. We can interface Arduino with a number of SILDs module available in the market. Then they also provide some hardware like LED interfacing. So that part is very good as a student point of view. Thank you. Hello.
Okay. So we are concluding here. Sanjay, very thankful to you. You have provided such a good sessions for our students and also sparing the time for the preparing these PPTs and modules as well as the presentations. Thank you so much, Sanjay Mistry, once again.
Thank you, sir. Thank you so much for this chance.
Okay,
And
as
we'll
student,
try to arrange one seminar once the situation is normal.
yeah, definitely. Because here we are not getting exact feel of the laboratory exercise. But if we have a normal situation, we will try to conduct the same session in our department with practical demonstration.
Okay, sir.
Okay. So students, we are going to share one feedback link. So kindly fill up the feedback link. Also, we will provide one certificate for participant of this program. Thank you very much to everyone once again. Thank